Hello, this is William from Visual Components. In this video, I'm going to show you how to create a plugin that can highlight dynamic components in the 3D world. Now, your first question might be, what is a dynamic component? It is a component that is created during a simulation. So I'm going to show you how to get a handle for a dynamic component when you start or stop a simulation, how to change the material of a dynamic component, and how to use lists to filter and select the types of objects you need for your functions and other types of operations. To get started, let's go ahead and run Visual Studio as an administrator. So in my Windows toolbar, I'll do a search of Visual Studio. I'll then right-click the program and then click Run as Administrator. Let's now create a new project. So in Visual Studio, on the Start page, I'll click New Project. And we're going to create a new class library. Notice I'm using .NET Framework 4.5 and the language is Visual C#. Let's now rename our class library to be Example 005. Click OK. And now Visual Studio will create the project for us, which you can see here in the Solution Explorer pane. Let's go ahead and rename class 1, so I'll right click, click Rename, and let's just keep it simple and call it My Plugin. Press the Enter key, and I'm going to click Yes in the dialog, and Visual Studio will just rename everything for me elsewhere. Let's now add the references for our plugin. So in the Solution Explorer pane, I'll right-click References, click Add Reference, and in the Reference Manager, go ahead and add those 3 libraries we've been working with in previous video tutorials. So you can find them in your Visual Components program files, and they're called ux.shared, caliburn.micro, and create3d.shared. And we need one more component from the .NET Framework. So in the Reference Manager, I'll click Assemblies, and that component is called System.ComponentModel.Composition. So select this checkbox here, and click OK. And we can see the references have been added. So let's now add using statements for these references in our code. So in the code view, let's add some white space. And we'll do a using statement of System.ComponentModel.Composition. Using Caliburn.micro, using Visual Components, Create3D, and using Visual Components.ux.shared. Let's now implement our class as a plugin. So in the class declaration, let's add a colon and implement that interface called iPlugin. I'm now going to point at the interface, and I need that light bulb. Show me the light bulb. There it is. So click the light bulb, and then click Implement Interface explicitly. Now, we're primarily going to be using events in this tutorial, so you don't need to worry about the exit and initialize methods. So you can go ahead and comment out this code or just remove it, which is what I'm doing. And now, we need to get an instance for the application, and when the simulation is stopped, we need an event handler, which can then call a function for us for changing the material of a dynamic component. So let's use the constructor of our plugin, so my plugin, parentheses, add those curly brackets. And now we need to import an instance of the application in our constructor. So before the constructor, I'm going to add an importing constructor attribute. And now that first parameter for our constructor will be of iApplication. So we're going to import an instance that is a type of iApplication. And the type of our first parameter is going to be of iApplication, and we'll just call it app. And now we want to get a handle for that instance after we construct our plugin. So I'm going to add a private variable that is of type iApplication and just call it app. And then we'll say this.app is equal to that instance imported by the constructor for our plugin. And now to get the event handler for when the simulation is stopped, we'll use the application object, so this.app.simulation. And now if I add a dot or full stop, you can see I now have the properties of the simulation. And if I just type a capital S and just look for start or stopped, you can see you have these 2 events here. So simulation stopped. This is an event handler for when the simulation is stopped in the 3D world. And the simulation started is when you start the simulation. So let's say we first want to change the material of a dynamic component when we stop the simulation. So I'll add this event handler, and then after that I'm going to add a plus sign and an equal sign. And notice if I press tab, it creates a function for me that can be tied or added to this event handler. And let's go ahead and rename this function to be highlight dynamic components. And I'll press enter. And now what do we want to do? Let's first find the material we want to assign to our dynamic components. So a material is of type I material. And we'll just call the variable mat for mat. And then I'm going to use the application object, so this.app. Or you actually don't need to do that in this case. You could just type app if you wanted to. And now we're going to use a method with the application object called findMaterial. So this finds a material by its name, and you can have to indicate whether the name is case sensitive. So we'll use findMaterial. And let's go ahead and color the dynamic components red when we stop the simulation. So I'll add a first argument of red. And we won't worry about case sensitive, so I'll just pass a false value. And now we need to know how many components in the simulation are dynamic. So let's use a for each statement. So for each iSim component, comp in app.world, so we now have a handle for the 3D world itself, and notice it has a property called components, which you can see here. So we now have for every component, we want to know if it's dynamic, so let's add a if statement. So if comp.is dynamic, and this property will tell you whether it's dynamic or a static component, and so it'll return a true or false value. So if the component is dynamic, so if is dynamic is equal to true, what do we want to do? Well, we want to assign the material of the component, so comp.material equals that variable for our red material. And what we need to do now is go ahead and export our plugin. So in the class declaration, before that, let's add an export attribute for a type of iPlugin. So just to quickly review, we got a handle for the application in our constructor for our plugin. We then tied a function to the event handler called simulationStopped. And in that function, we got a handle for a material of red. And then if any component in the 3D world is dynamic, we're assigning it a red material. Let's now go to the project menu. Click Example 005 Properties. And for our assembly name, let's add a plugin prefix. So plugin dot, followed by your assembly name. Let's now go to Build. And our platform target is a 64-bit software. And for our output path, let's build this in our Visual Components program files. So I'll click Browse. Let's now go to our program files. And I'm using Visual Components Premium in this case, so I'll select this folder here. Let's now debug, so I'll go to the Debug tab here. And let's test with the software while we're creating our plugin, so I'll select Start External Program. Let's now find the executable for our 3D product. So go back to the program files. And you want to find this executable called visualcomponents.engine.exe. Let's open that. Let's go ahead and save our work, go back to our code, and start debugging. So the software has loaded up. Let's now add a feeder and a conveyor. So in the eCatalog panel under Models by Type, I'll click Feeders. I'll add a basic feeder to the 3D world. And let's zoom in on it. Let's now go to our Component Properties panel. And let's set the interval for how often it creates a new component to be 0.5. And that's in seconds. Let's now add and connect a conveyor to this interface of a feeder. So in the eCatalog panel under Models by Type, I'll expand Conveyors, click Visual Components, and since I have the feeder selected, I'll go ahead and double-click this item here called Conveyor. Notice we do have an automatic plug-and-play feature, so the conveyor automatically connected itself to the feeder there. So if I now start the simulation, notice the feeder creates these cylinders, and what do we expect to happen when I stop the simulation? Ho-ho, you guessed it! It now highlighted or colored these dynamic components red, so I can clearly see that these are dynamic. So if I now start the simulation again, notice they're still red, but the new ones that were created are no longer red. So what we need to do is when we stop the simulation and we restart it, we want the dynamic components to go back to their old material. So we can fix that in our plugin. So let's reset, and notice the dynamic components disappear. Let's go back to Visual Studio and stop debugging. And before we assign that material of red, let's first get a handle for what the component's original material was. So let's create a list of materials, and that list will contain a type of iMaterial. And I'll just call this original component materials equals new. And it's going to be a new instance of a list that it contains iMaterial type. let's go ahead and before we do anything, let's clear the list. So let's say original materials dot clear. So this is going to remove everything from the list. So we're starting fresh because when you start a simulation, components will be created, and then when you stop a simulation, some of those dynamic components may have already been deleted from your layout. So you want to make sure that you're starting fresh and you have what's just currently in the 3D world. So we're going to clear the list, and then after we do that, before we assign the material, let's add the material of that dynamic component to our list. So I'll say original component materials dot add, and that's going to be the component dot material. And now we need to assign that original material to the component when we start the simulation again. So we need to create another function that we can tie to an event handler. So in the constructor for our plugin, I'll say this.app.simulation.simulation started, and I'll add that plus sign and equal sign and press the tab key again. And let's now rename this function to be clear highlighted dynamic components. And in our function, let's get a handle for the components in the 3D world that are dynamic when we start the simulation. So I'll create a variable that is a list of type iSimComponent, and I'll name my list components and set it equal to be a new instance of a list that is of type iSimComponent. Let's now add items to that list. So I'll say components.addRange, and this allows you to add items from another list to the list that's calling this method. So components.addRange, and let's get that list of components from the application's 3D world property. So app.world.components. So this returns the list of components that are in the 3D world, all of them. But we only want the components that are dynamic. So I'm going to use a where function now, parentheses, and let's go ahead and use a element name of C. Then we'll use a lambda here. So in this case, the element I have working with right now is a component. So C dot is dynamic. If that component is dynamic, so is equal to true, we'll then add it to the list. So what we're doing is we created a list of components. We're then adding the components from the 3D world to that list where that component is dynamic. And once that component, we have it, we then want to set its material back to its original. So let's use a for loop. So for, and we want to index or apply the materials based on the length of both the components list we just created and the original component material list. So they should match up. So we'll say components.count. Let's now loop through that list of components we have. So I'll use components square brackets I. So get the element at that index value. We'll then get a handle for its material property and set it equal to the material that is at the same index in our original component materials list. Now I'm going to start debugging, and I'll explain this once again because sometimes you can get confused about this. So the application has loaded up. Let's now add a feeder to the 3D world. So let's add that basic feeder. There it is. Let's now add the conveyor that we were using before. And just make sure it's plugged into the feeder. Let's now set the creation interval for that feeder to be 0.5. And now when I start the simulation, you can see it's creating the cylinders. And we'll just wait a couple more seconds and now stop the simulation. And we can see that our plugin is still working. It's changing the material of the dynamic components to red. And notice here is the first component that was created during the simulation. So the material in that materials list we created is this component's material. And here is the last dynamic component that was created. So the end of that list is this material. And when we're going to start the simulation, the first item in our components list is going to be this dynamic component here. And this is going to be the last one. So you can see how the materials can then be assigned back to it. So if I start, you can see, yep, they go back to what they were before. So if we stop again, they're now red. And if we start again, they're now back to their original material. Great. Let's go ahead and stop the simulation. Go back to Visual Studio and stop debugging. And I want to give you another example of how you can filter out lists. So when we started the simulation, notice that we selected components from this list here, if their dynamic property, their isDynamic property was true. Why can't we do the same here when we stop the simulation for our original component materials list? Well, we can. So after we clear the list, let's then say original component materials dot add range, and we'll do the same thing we did in our clear highlight dynamic components method. So app.world components where, and we'll name that element handle component and use that lambda. It's an equal sign followed by a greater sign. And now the element we're working with is a component because it's coming from this list here. And then we'll say material. Actually, it needs to be, we need to first make sure it's dynamic. We don't want to add the wrong materials to components. So we'll say component is dynamic is equal to true. And then after we have that, after we know that the component is dynamic, we have a handle for it, and then we're going to select its materials. So we'll then add a select function here, and it's the same thing again. We'll name our element to be a component, and then the element we're working with is called component. Sorry, I need to add that equal sign and greater than sign. Then say component dot material. And then what happens is that in our original component materials list, we're adding the elements from this list from the 3D world where the component is dynamic, but we're selecting just the material of that component. And that's what's being added to our list. Let's now clean up our code. Since we're getting the materials of all dynamic components at the start of our function, we don't need this instruction here for when we loop through all the components in the 3D world and then add the material to the list. So I'm going to comment this line here. And when you're creating lists, you might see in examples where you actually just assign a new instance of a list to your variable instead of, first clearing the list and then adding values to it. So this is kind of redundant here. We can accomplish the same task in just one instruction. So let's comment this line of code here and the next line of code. And now we'll use that variable of original component materials, and we're going to set it equal to a new list that we create from app.world.components where the components property is dynamic is equal to true. Select from the component the value that is assigned to its material property. And then for all those elements in their materials, make that into a new list using this method here called toList. So instead of two instructions, we just have one. And this is sometimes easier to understand instead of, where you clear the list and then you gotta go back and say, okay, what is happening here? But we can see here we have a variable and we're assigning a list that we create using these conditions. And we could do the same for when we start the simulation. We just have to make sure that we're not using any null value for our original component materials. So let's actually go up here at the start of our plugin, and instead of initializing that variable, original component materials, with a value, just define it or declare it. And let's now do the same for when we start the simulation. So that components variable, let's just declare that. And then instead of using that add range method, let's comment this out. And then we'll just assign that components list a new list using app.world.components where the component is dynamic property is equal to true. And let's make sure we have that set up. And we need to make that into a new list. So the list will contain the components that their isDynamic property is true, and then our for loop will take care of the rest. But we want to make sure that this original component material is not null. So let's add an if statement. So we'll say if original component materials is not null, then do what we did before. Otherwise, this function will just do nothing. It'll just return void. So let's copy and paste that code. And let's go ahead and test. So I'll save everything and start debugging. And the application is loaded up. So I'll now add a feeder to my layout. And let's now add and connect a conveyor that we're using before. So just add it there. Let's now select the feeder and set its interval property to be 0.5. And if I start the simulation, everything is working smooth. Very good. Let's stop. The dynamic components are highlighted red. Start again. And the plugin is working just like we expected. Great. Alright, this concludes the video. Now if you have any questions, please feel free to visit our forum at forum.visualcomponents.com. And the project and plugin we created in this tutorial, you can find a link to in the video description. So as always, have a wonderful day.